This tutorial is about Rietveld refinement using MAUD software. This is you can download on MAUD page. MAUD, yeah, you can download from here using. I'm using the latest version, this one. Okay. So yeah, 2.94. This is the layout. This tab is for dataset, and then this eye looking button is to show the property. When you select this dataset, you can see what you can adjust here. There's a general data file. When you load your data, it will go to this tab, and then the exclude region. I never use this one. And background, you can select between polynomial, interpolated, background big. Usually polynomial. You can add the term here, like that. But I prefer something like four polynomial background. Value is here. When you right click, you will see it fixed. But when you start to refine, it will change to refine. Okay. Oh, and also here the setting. When you click this in the instrument, usually I usually use just only the general tab here. You can select all the instrument. Okay. And then when you check this, you can select this, you will see you can name your instrument. Alright, here. Okay, I will send the CBN. This is Booker. I think Booker Advanced. Advanced. I think Broker Advanced 8. Okay. Then usually for X-ray tube, usually copper alpha. You can select other as well. Just make sure. And then detector type, we cannot select not curve position sensitive, but usually just check this scintillation as well as I think standard you can select as well, but usually I check this scintillation. Okay, and then the instrument broadening, you can choose Cagliotti, pseudo-void. And then here you can see when you select the option, you can check the asymmetry. Okay, this is the half width, half maximum, Gaussianity, and other. Okay, nice. Okay, yes, okay. This is the phase where you can put your CIF or crystallographic information file. You simply drag and drop there. But let us start from this is XY file. Okay, go to the position sensitive detector, then you will see up to few, I think 10, more than 10 digits, but this is only just numeric, and we just drag and drop there. Yeah, Okay, you see, this is the data, right? Very good data, up to 3000, but the peak to background ratio is very, see, say this is 3000, but the background is something like 50, so 3000 divided by 50 is something like 60. Okay. We change this to data file, what's HNMO, okay, probably just something like that, and then move to the face tab, do the same. This is I create from Topaz, but other CIF file also can do. Okay, simply double click here and change to O and oh sorry and O3, not wrong. Okay, then we check the component chemical sum, yeah. Okay, it's monoclinic phase. This is the A, B, C, and the beta. This is the structure. You can check it out from here. Okay, so this is the structure, and then is, or if you want to change, you simply change from here. If there's a oxidation state, yeah, you just simply change from there. This is the position: nickel, manganese, chromium, and oxygen. If you have a fragment, if you have a substitution level, you can put here. This is the microstructure, where you simply, this is usually for crystallite size, you just change from here to something like Popa rules. Usually, if there is no in anisotropic, then you simply use isotropic, where you can select here crystal size, something like here. This is 100 nanometer fix. I usually, because this is not nanomaterial, so I change to 10,000 angstrom or 1,000 nanometer or 1 micron. Here micro strain is small, but I prefer to change to 0. And then there's advanced mode for texture. Here you can select the harmonic wind, exponential wind, MTEX, McDoulas, and then other. Okay, then also there's a strain, if there's strain present. Okay, and then for magnetic phase, yeah, you can also do that. Okay, now let's see what is going on. First of all, I just simply click one of these 3 buttons. This button is for refine. Okay, but there's a different function wherein, like a bulb, like this refine wizard. Here you see, if I check this and I push this button go, then what the software will do is to refine the background and scale parameter. Just that, and then previous meaning background plus and scale plus some basic parameters. Also, that this here complete analysis, where you check quantitative analysis, it will go refine some other things complete, like lattice parameter, the crystallite size, as well as the also background intensity, Cagliotti term, this Gaussian and Lorentzian, as well as the temperature factor. You will find if you select this. Okay, but let us just simply background and scale. So when I select this, alright, it will here simply just background and the scale parameters. But you can see since it constrained to the limit was the data. So if your model is out like this, then it will not go to the scale will not go to fit the data. So what we can do is I usually go for quantitative analysis. I seldom use this one. Okay, now you can see it's much better. Okay, and now if I want to repeat, I'll just simply do this hammer like this button. I will repeat the quantitative analysis. I see. Alright, very well, done very well. Now I'll see what the refinement are doing. Oh, probably I just check this one. Yeah, all the parameter list. When we expand it all, you will see these all refined or fixed here. This is a background function was refined 1, 2, 3, all the background function, and up to 4 polynomial. This is the constant. Then here also refine the intensity, the 2 theta offset. Okay, the offset. This offset was shift all the pattern to match the data, and then you can check this lattice parameter as well, crystallite size, as well as microstrain, also the temperature parameter, and I think that's all. Yeah? I think that's all. These all the atom. Alright, so I just simply close it. Then if you let me check. Let's check. Okay, this is the chi-square is 1.03, but the RWP is 12 due to the R experiment. The XP is 11, so this one cannot be lower than this one. So this data, because of the maximum intensity, is 3000 something, but it's good enough. If you increase it, RAXP will be lower than 10%, as well as the RWP, but the chi-square will be difficult to reach even 1.2. Okay. Now it's time for us to plot the data. So either you use this by copy it and then use now you can simply copy and paste it like that, or if you want to use other software, so you must go to tools and export the experimental and computed data. Save it under okay, since it's CIF file, I won't use CIF file, but let's name it as TrueNEM06, but by txt, okay, or result, or plot.txt. Okay, now we close it. Now here's the data. Sorry. Okay, I rename. So sorry, the CI file text. Alright. Now we just simply double click, and then you might need to erase this part. Okay, erase this part, and then check for bottom part. You also need to erase this one. Okay, save it. You can open by Excel. Yeah, just open the file. Wait a minute. Open or file. Open this file. Plot. Now you go for space. Okay. Then delete this part. Delete as well. Also this. Let me check. Okay, delete this part. Let's try to plot it. Okay, let's see. Plot this and this insert. Okay. Let's change it. Oh, sorry. Just simply we plot by plot using this. Okay, and just remove this chart title. Option. I might need to change. I might need to change this. Oh, wait a minute. This one. Oh, this data point. Or I just want to show you how to plot it, and then the second part is this is the second one. Then I just select data. Okay, this series 1 is for the, okay, let's name it. This is the experiment, and then experiment, right? Suppose then I add another series name is the calculate, or just call. Okay, there's X value from here. Okay, I just set it like that. Then B is this guy. Okay, it's okay. Let's see. All right. See, but as you can see, I don't know how to modify this file. Probably. Let's check. Call. Can I change to edit? No. I don't know how to edit it. But anyway, you got the idea. I usually use this software over here. Okay, just simply drag and drop this data. Okay. So why plot error? Oh, I must close this one first. Now move over here, 1 to 2. Okay. I change to 1.5. The circle, and then the width of the line of the circle. You can see, yeah. Okay. Double click this, change to 1500, and then probably minus 100. See, then again change to 3. I change to no dot, change to solid line, change the color to red. This is the experimental that the plot for the calculate data. See, all right. Now you can see the. Now if you want to modify this, like the tick or the tick you want to tick be out, like I usually put the tick out, label something like 20, right -5, okay, something like that. But if you see the increment is too huge, you can size to 5, like that, as well as this. Take out label 20 or usually 18 down 5, like that. So I must do probably, okay, this one could be 5. Great. Label is 18. Okay, if you want to put like want to insert the x-axis like 2 theta like this, degree, you simply just put it. This is to peak 20 and port. Okay, like that. Insert y intensity counts. Okay, put here. This one will be 20. Okay. Now you simply copy the graph. Okay, and then yeah, here you go. Thank you.